Let us discuss one more problem that is also based on Lami's theorem. The statement says that a string of 2 meter long is tied to the ends of a uniform rod that weighs 60 Newton and is 1.6 meter long. The string passes over a nail so that the rod hangs horizontally. Find out the tensions in the string. Now there are two things. First is a rod, second is a string. Now let's say this is a rod. Now this rod is having the length of 1.6 meter and the weight of this rod downward, that is 60 Newton, right? The weight is 60 Newton. Now there is one string that is 2 meter long. It is tied at this end and at this end of the rod. I'll show you. Now it is just similar to this one. Now this rod is 1.6 meter long, weight 60 Newton, and this is a string which is tied at this end and this end, 2 meter string, right? Now the second part of the question is the string passes over a nail so that the rod hangs horizontally. It means it is being hang like this. So this string is passing through a nail like this so that this rod hangs horizontally. Now we have to find out the tension in the string. So we have to find out the tension in this part of the string and in this part of the string. Now first of all we will draw a free body diagram as per the given question. So we assume that this is, first we can say this is a rod, right? And this rod is tied with a string that is passing through nail. Now this point is a nail. It is tied with two ends like this, and we name the corners also. This is the point C, let's say, and this end is point A and this end is point B. Now this string will have a tension in this direction, we say T, and this will also be T, as it is equally balanced on both the sides, so the tension will be same on both the sides, right? Now this rod, it is having a weight of 60 Newton, so we know that weight will always act at center as it is horizontally placed. So this is the weight, 60 Newton. Now the length of this rod is given as 1.6 meter. So 1.6 means if I say from this point, it will be half because balanced in both the sides. So I can say this is 0.8 meter and this will also be 0.8 meter. Right? Now let's say this is the point D. Now if I join this just to make the problem more clear, now these are the two triangles, and if this angle is alpha, this will also be the same alpha as equilateral triangle on the both sides. Now for this given problem we draw the free body diagram or the force system. Now what is the force system? Let's say this is the point, this is the first tension and this is the second tension. We are representing the same direction. I have taken this T, this side here, this side we have taken here, and the weight is downward, so we are taking the weight here W. We don't know the value of T, so we have to find out these T values. Now if we calculate the angle, now this angle is alpha, let's say this angle is alpha, so this angle will be 2 alpha. So is it okay how I am calculating this? I'll show you this again. This was another T and this was angle alpha and this is also alpha. Total will be 2 alpha. So now we are representing it in this way. In the diagram we are representing it like this. We have taken the line of action of force, this line of action of force, this. So this is what T here in this side, this is what another T tension this side, and if this is alpha plus alpha 2 alpha, so this will be also 2 alpha, right? Now in the same way if we calculate this angle, this will be 180 minus alpha and this will also be 180 minus alpha. How I am calculating this angle? Let's say the same, this is T, this is also T, and this is the direction of weight. Now we have to find out this angle, this one. How can you find out this angle? Now this angle will be 180 on this line, right? And we are taking the angle from this point to this only. So this angle is, we know that alpha, so the remaining angle will be 180 minus alpha. So in the same way we have taken this 180 minus alpha, right? Now we apply the Lami's theorem. Now Lami's theorem says that weight divided by sine of opposite angle, that is 2 alpha, tension divided by opposite angle, that is 180 minus alpha, this tension divided by opposite angle, that is again 180 minus alpha, sine of these, right? So got this point? Now as AC is equal to BC, now we know the length of these, that is equal to how much? 1 meter, and CD, the total length of this top is 2 meters. So 1 meter on this side, 1 meter on this side, from this to this one, this to this one. So that is 1 meter. So can we find out the value of CD? We have the hypotenuse, we have the base. Can we find out this perpendicular using Pythagoras theorem? So CD will be root of 1 square minus 0.8 square, and that will be 0.6 meter. Now sine alpha, if I say sine of this alpha, can we find out the value of this alpha? Sine alpha will be sine of this alpha, that is equal to perpendicular over hypotenuse. Now here, if this is angle, this will be the base, CD is the base, DB is the perpendicular, BC is the hypotenuse, right? So perpendicular means DB upon BC. So we have the value of DB, that is 0.8. So it will be 0.8 divided by BC. BC is 1. So this is DB by BC, that is 0.8 divided by 1. So sine alpha is 0.8. Now same we can find out the cos alpha. Now cos alpha is base over hypotenuse. Now what is the base here? I have told you that is what? CD. Now we have calculated CD, that is 0.6, hypotenuse 1. So this is 0.6. Now in this equation, Lami's theorem, can we find out the value of tension? Because we know the value of weight. If we equate this one with this one, we can find out how. We can say the tension is unknown here. Tension will be equal to, that is W weight into it will go here in this side, so W into sine of 180 minus alpha upon, that will be sine 2 alpha. We know the value of weight, that is 60 Newton. 60 into sine 180 minus theta, that is sine theta. So this is sine alpha only divided by sine 2 alpha, sine 2 theta. Sine 2 theta, it is equal to 2 sine theta cos theta. So this is 2 sine alpha cos alpha, right? So if we fill the value, this will be 60 into sine alpha. Alpha, we know the value of alpha. Sine alpha is 0.8, right? So this is 0.8 divided by 2 sine alpha, 2 into sine alpha, that is 0.8, cos alpha, that is 0.6, right? So in this way, when we calculate this, we get the value of tension, that is equal to 50 Newton, right? So this is the application of Lami's theorem. Very easily we can find out the required tension or required force when the three forces are there. Thank you.